Hello. Languages like Go and Rust let you compile your code into a single file binary. This has a number of advantages like simplified deployment, no dependency hell, and predictable behavior. Basically, it means you can give your binary to users and they can run it on their system without any other steps. This is obviously a cool feature, and I wondered if I could do something similar in ClojureScript. NBB is a tool that lets us do ad hoc CLJS scripting on Node.js. You can use npm to install Node libraries and dependencies, and then simply interface with them by requiring them. As I quite often write utilities using NBB, I wanted a way to package these up into a single file that makes deployment simpler. And most of the instruction for doing this is available in the NBB repository under doc bundle. There they describe how to use the bundle command and Vercel's NCC tool. And you can find the CLJS binary demo on my GitHub. The main solution is in package.json, and there you can find the tools required and the build steps to do that. Hello world.cljs contains a full example, including command line parsing, but let's take a look at a simpler example to get started. We can create a very simple hello world script, and then we run that with NBB. As you can see, it just prints hello world. Now let's run our build step, npm run build. You can see 3 steps happen here. The first is the NBB bundle step. What this does is bundles up the CLJS script into a single file called helloworld.mjs. That basically inlines the CLJS as a string and calls NBB from inside JavaScript to run it. The second step uses Vercel's NCC command, ncc build helloworld.mjs, which compiles the JavaScript file and all of its dependencies from node modules into dist index.mjs. The third and final step concatenates this special hash bang together with the code itself into a single binary called hello world. And we can see that that's been created here with 1.1 megabytes in size. Now, something to note is that this isn't a true binary like Go or Rust would create. It still depends on the node runtime. But I actually think in this case, that's an advantage. You don't have to create separate binaries for every architecture. And as long as the user has some version of Node 18 or greater installed, they'll be able to run it. Of course, that demo was just a print statement and didn't have any dependencies. Let's see what happens with a more complicated example. In this example, we're using clojure.tools.cli to parse arguments. We've imported the file system, and we've also got an external library, Express, which is a web server. And what our main function does here is use tools.cli to parse the arguments and run whichever option you selected. If we run it with no arguments, we get the help. And let's try running a small web server. And we go to localhost 8000 and we get hello world. So that works perfectly. Now when we run our build step, we get a new hello world binary. Let's copy that to our temp file. Then we'll go into the test folder. And as you can see, there's only one file in here, hello world, and no node modules. And so Express is not available from the file system here. We run hello world and we see the help. And then we run our server, which works the same way as before. And we can access localhost 8000 and see the demo. So what have we done here? We've taken a ClojureScript file running on NBB and Node that depends on the Express library being installed in Node modules. We've bundled it up into a single file binary, and that binary can be run on Node version 18 or higher on any machine, regardless of the architecture. So to deploy this server somewhere else, we can simply copy this file and run hello world. I think that's a pretty cool feature with different trade-offs to the Go and Rust style binaries, and I'm hoping to use it more in the future. And if you want to get this working yourself, you can check out the CLJS binary demo on my GitHub. So good luck with your single file compiled ClojureScript binaries. Enjoy.